I guess I'll just call you guys up one by one here. So since you're all by yourself over here, Ben Hamner, who is the CTO and co-founder of Kaggle. Ben, come on up. I think many of you guys know Kaggle here. We've got Vijay Gill from Salesforce, SVP of Engineering at Salesforce, and also an alumnus of Google, Microsoft, and AOL. And we've also got my good friend Sam Shah of SkipFlag, CTO and co-founder at SkipFlag. And before that, one of the top engineers working at LinkedIn. So, guys, thanks for coming. Great to see we've got some folks here eagerly waiting the happy hour. So we're going to do our best to make sure we keep the pace brisk. We will leave time later on for some Q&A from the audience. But I really wanted to start out with one question that we talked a little bit about in the green room, which is, data engineering didn't exist 10 years ago. Many of us were doing stuff like that, but we didn't have a name for it. And I thought I would start by asking you guys to share your own personal anecdote for the gnarliest data engineering pipeline you ever worked on and why. So I'm going to start with, I see Sam, maybe leaning in here. Love to just hear a story from your background about a gnarly data engineering pipeline and why.
So when I first got into data engineering, it was working at LinkedIn. And when I started, we had this people you may know system, which, as the name implies, recommended people that you want to connect with in your network. It was kind of an n-squared problem. So everyone on the site, you want to map to everyone else on the site. And when I started there, the product hadn't updated on the site for 6 months because they just couldn't get it to run. They were just trying. And eventually, this gnarly problem, all these SQL scripts. I remember we printed out like the data flow diagram, and we needed to get a plotter to figure out how things actually worked. Eventually, we did move it to Hadoop and actually got it running. And so that was like the gnarliest and most challenging data problem that I ever worked on.
See, that's what happens when you let data scientists build products, right? You end up with that. Yeah. There's SQL scripts, that don't even, with tables that are all over the place.
Exactly, with all variables and one-letter variables.
Later, you did co-found your company with, I think, the guy who is responsible for that. So that obviously something good happened there.
Right, exactly.
Pete Skomarok, some of you may know. Vijay.
So let me draw this. My data problems are more around data fidelity and reproducibility of the pipelines. So thankfully, most modern systems can work at scale. However, the engineering problems that we run into previous jobs and so on and so forth is, are you getting the right data? Where are they coming from? Are the data complete? Is the pipeline reproducible? A concrete example is that we had an old log shipping system where the processes could write to disk. And then periodically, from a cron job, it would package up those log files. And this is like app log, syslog, whatever. And then FTP them over to a collection point, and then you would decompress and process them. We switched that to a Kafka-based system, so you were quote-unquote quasi-real-time. The problem was, of course, so first of all, the reason we switched to Kafka was we didn't want processes having arbitrary write permission to disk, because that kills non-repudiation. If any process can arbitrarily write to a file on disk, you can't repudiate, so you can repudiate what's in the log stream. So to prevent non-repudiation, we have to switch to an in-memory thing where data lineage is marked on ingress by which process put the data in, tagged it, and then sent it over. So the first thing was you want to remove access to disk and only use a single process authorized to spill to disk in case the buffers couldn't write to stream. And the problem with this was that the periodicity of the FTP pipeline was on the order of hours. So as a result, even if processes were lagging or they were out of order, the periodicity, the window would close, and you would actually get all the data that you wanted for that period kind of collapsed. So when we started doing comparisons between the real-time data and the lagging data, of course, there was discrepancies because at scale, nothing is ever consistent. So this is one of the things you have to learn, right? And you're running into Six Sigma problems every day. And so reconciling all of that, moving the windows around, which kind of led us to the CAP theorem of data consistencies like accuracy, velocity, and volume. Pick two. That, I think, was the biggest learning, because we thought, hey, we'll put it in Kafka, it's awesome, we'll be all real time, and years later, we finally got something working.
I heard a story that Facebook at one point decided to move all their logging to real time. They had this big internal initiative, and then they ultimately were like, this is way too hard. And they just went back to batch. Ben, gnarliest data engineering problem you've worked on?
Let's see, wow. There's a lot of different choices here. One thing that a lot of people actually
don't. I think you got to hit, why don't you do this? Okay, there you go. Got it.
Okay, take two. Wow, that's a lot better.
Yeah.
Okay, so we've touched a ton of different problems at Kaggle, so this is actually a really tough one to pick. But one thing that a lot of people actually don't know about Kaggle is, in addition to competitions and a lot of the other work that we've done, we actually spent a lot of time working with the oil and gas industry and what we kind of on the surface seemed like a really fascinating machine learning problem. How do you get all the data that you can and train machine learning models to identify here's a good spot to drill for oil and here's how you should drill it? Because it seems like it's machine learning models on top of machine learning models on top of machine learning models for first like develop a geophysical model of how the earth works, and then for the likelihood of oil being there, and then how the drilling would work on top of that. Seems like a really fascinating problem. Then we started growing a bit deeper in it, and one of the operating principles that we keep at Kaggle is all the work that we should do should be end-to-end reproducible with a single command, just because there's a lot of different benefits you get from focusing on reproducibility and making it easy for you to make one change in one part of the pipeline and see it propagate through, or have a colleague come in and work on it as well. So we started applying this principle to this problem and started getting some data sets. And we discovered that data wasn't coming kind of in nice, clean databases, but instead was coming to us in the form of thousands and thousands of PDF documents that have been saved in different formats, or hundreds and hundreds of Excel documents that are dumped on a different server to us. So we end up with a incredibly gnarly, like 2,000 line make file that called off to a bunch of sub make files to try combining all these results together. And we spent probably about 95% of the time on parsing PDFs and pulling the relevant data out of PDFs in a clean and reproducible way. And about 5% of the part that we found super interesting for the machine learning part. And that, for a lot of different machine learning problems, that type of ratio isn't very uncommon.
Yeah, I once had to get disks from a client that had like an old Oracle database format on it and figure out whether it was like big endian or small endian. I think I almost left my job when that happened. Okay, so we've set the table with some gnarly data engineering pipelines. I'm going to go to Sam because you did work at LinkedIn. You guys thought a lot about teams and people, and we were talking earlier, and you made the point that when you're building out, when you're doing data engineering, and one of the lessons learned from a decade of data engineering, that's the name of our panel here today, is thinking about how data engineers work in the organization. So I'd love just maybe even specifically your own experience. How did it work at LinkedIn, and how do you think it ought to work, if any differently, in the modern era?
Yeah, I think one of the big changes from like kind of then and now is the way most data teams are structured, or the way that I think data teams should be structured. So historically what happened was you had data engineers kind of doing a lot of ETL, transferring things from various systems and making them consumable by data scientists. And that's very much like a thankless kind of job. It's very difficult. It's hard to understand because you have to horizontally understand the business to know how you're going to transform that data. And then on the other hand, you had data scientists who maybe knew some SQL or some MATLAB, but they couldn't really take their ideas and put them into production, right? They needed data engineers to help. And that was very difficult and unhappy from both ends of the spectrum, because data engineers didn't want to work on the ass end of projects. And data scientists really had trouble like getting data and like actually taking their ideas and putting them into production. And I think what's happened now is a couple of things. On the data engineering side, the tools and the frameworks have gotten a lot better, especially from like the various cloud providers, that it's easy or easier to kind of go spin up data pipelines and get that stuff going. And the frameworks have gotten easier, so you can plug kind of your transformers in there. And then on the data science side, what's happened is that most data scientists now kind of know Python. That's become like the minimum standard for, because of all of NumPy, TensorFlow, all the various libraries there. So you have these data scientists who have almost become ML engineers on one end, and then the frameworks have gotten much easier. So what now you can do is data scientists can more work end to end and kind of own their ideas. So you get a lot more iteration velocity through autonomy. And data engineers work on scaling systems and work more on frameworks and horizontal tools. And that's like, I think, a better way to structure data teams today.
I'm going to pop to Ben because to talk a little bit about tool chains, and then I want to talk about security and access. But Ben, so you nodding when you said, data scientists are learning more, getting a little bit more savvy. What have you seen in terms of the tool chain and how it's changed in terms of people who are building, whether they're data scientists who need to do some data engineering work? What have you seen the evolution of the tool chain in the last couple of years?
One of the big differences, if we look at the history of the Kaggle community, is kind of scroll back in time to 5 or 6 years ago. MATLAB would have been one of the most common languages on Kaggle, which penetrated a lot of universities, and thus a lot of people kind of learned it in universities, but it's a terrible language from a data engineering standpoint, or to think about how to build a scalable system. And
it's great if you love pointers.
And then one of the things that we've really seen emerge over the past 5 or 6 years is really twofold. First, as a base layer, Python and R have really started to dominate the ecosystem in terms of base languages that almost everyone or everyone's becoming familiar with, and even if they don't know deeply, can operate and use APIs that are available in those languages. And then secondly, the APIs have gone from almost non-existent or proprietary to very, very well put together through tools like scikit-learn, which lets you, with a couple commands, train against 100 machine learning models and evaluate those, to things like Theano and Keras and TensorFlow, and the kind of massive explosion of deep learning frameworks over the past 1 to 2 years. So it's really changed from trying to write, the pain of writing a neural network or getting a neural network to work has gone from a massive team that a 5-year research project for a specific application to it's something that you can do over a 30-minute coffee while you're waking up in the morning.
So, one of I think the values we've seen as tool chains have gotten better is democratization of access to data inside organizations. So there's a lot more self-serve opportunities when someone can go and write a SQL query on their Hadoop cluster with Hive versus having to write MapReduce, which is what it was back in the day when I was a young lad. So I guess Vijay, you're talking about how access and security though are considerations that you've had to think about. Tell us a bit about how does access, security, authorization, how does this factor into the data engineering work that you're doing at Salesforce?
So I think to build on what both of my panelists said, one of the things that is happening is that we've switched from point-to-point apps where the data end result and the starting of the where the data came from was bespoke to that particular output or that particular business function. So in some ways, we started from where you had security through obscurity, in the sense that you needed to know kind of what business process was putting what data where to actually craft a query that would be relevant or could be potentially dangerous in some ways, right? So most people, it was too hard to do. So you had this kind of nice, safe, comforting thing where if somebody really wanted to, they could, but mostly they didn't. How many people remember using Telnet to access servers? Holy crap. Okay, I rest my case, right? Now, anybody using Telnet today, that would be a massive violation, right?
Fireable offense.
Yeah, 10 years ago, 15 years ago, Telnet was the only thing for the most part, right? So the same thing is now happening where now we're getting to platformization of data. So that starts where to make data easy to consume, what we've done is we've built these data discovery tools. For example, we run these bad jobs that will automatically create and seal data sets that are relevant. We have good data lineage now. Well, most people don't, some do, but you see where I'm going. We're going to have some idea what data lineage looks like, even though most people don't implement it. So at least we can now have data dictionaries and data discovery tools will tell you, data catalogs, what data are where and where they came from. Right? So now you can actually do a lot more damage with, for example, exfiltration of PII, so on and so forth, because now you have very nicely curated data sets that are available, and there's even a pointer to what lives where, right? Dangerous time to be. So we spend a lot of time now thinking around how to kind of put access on them, obfuscation of certain fields, for example, if you don't have access to those particular fields, but you want, like, for example, anonymized cohorts. Or more specifically, we take those data sets out of consideration if you run a query, if you don't have access to. And managing and manipulating that, tying that back to SSO or LDAP, Active Directory, control groups is actually a fairly significant data engineering problem on its own from a security and trust perspective. And of course, then there are things like encryption, on-disk encryption at the file level or on the table level. That I think will become more and more germane as these data sets get larger and larger, because I think now from a corporate perspective, a lot of the value is in data, and we've seen like people actively looking to exfiltrate data sets, because now with data you can actually do a fair amount of damage or exfiltrate IP.
Let me ask a quick follow-up, or maybe I'll start with Sam on the, when it comes to, you talk about encryption of systems and access, you had a very bespoke, federated, I guess is one nice way to call it. Siloed might be a more, denigrating way. But one of the, I guess the questions is, at a lot of organizations, edge processing versus centralized. What did you guys see at LinkedIn in terms of, was there, a shift over the years towards having more centralized processing of log files and signals coming from different systems, or was it more decentralized, or did that pendulum kind of swing in different ways while you were there? And I'll layer on the question of standards. You talked, Vijay, about how there were no standards. Everyone was doing their own thing. How did you see that evolve at LinkedIn while you guys built your infra?
I think the value came from when we were able to centralize the data and actually create a data lake, and that. Sorry, I think the value actually came from.
By the way, has yours been off the whole time? Have you guys? Okay,
no.
Good.
Okay. I think the value actually came from when we were able to centralize the data and create that data lake, where we were able to join different data sets together. That actually provided the value, I think, and a lot of the pop that you saw with the data products. And obviously, the tension became there is how do you actually deal with that in a privacy kind of preserving manner. So what we ended up doing was ETL and things like that were all separated. So you made sure the data sets were actually separated, but they were available via the same singular kind of API or system. And we basically layered access controls on top of that. There was never really, or at least we never found a really great solution so that we made it really easy. But there was always access controls on top of things. And so it always became this tension between being able to move fast and being able to get the data and then having things kind of locked down. And that's just the policy thing that we kind of played with over the years. But I fortunately don't have a great solution of how you balance the tension there. So
Vijay, you tweeted out sometime in the last couple of years, and I quote, "The first job for strong AI will be data cleanup." Ben, you are a guy who's worked in the world of AI and machine learning at Kaggle. What have you guys seen for the prospects of AI to help us data engineers, if anything?
Well, by virtue of hosting so many Kaggle competitions and growing a large community, we've inspired a large community to think it's a really good idea to try optimizing the process of training machine learning models and evaluate doing the heuristic operations on top of that to automate training a model well, selecting the right model, and so on. Then from my perspective, that's the really easy part. The hard part is automating the process that comes before that and the data engineering problem, which is where we spend 95% plus of our time. And I think that's fundamentally a strong AI problem where it's very tough to do kind of that full end-to-end thing in a narrow sense. But I think there's a lot of hope for things like if your data's coming from a relational database, understanding that the relational structure, then automatically creating and mapping features based on that, or identifying if you're dealing with a stream of data, doing the anomaly and outlier detection, and figuring out something changed and something's broken, and then raising that back up to a human reviewer, and instead of having the human reviewer need to go and investigate down and figure out from the top level, something broke with the end result of my model, where on earth did that break?
Mm-hmm. I talked to a financial institution 2 days ago that processes billions of dollars of credit card transactions, and they confessed when we went in with them that today they still cannot resolve the total amount of transactions that happen at Starbucks, because even the transaction logs themselves are still so unclean that they have yet to find a better way than actually shipping all of the data to an overseas group that just goes through line by line and does that classification. So kind of crazy. One of the things we also talked about, and I thought would be relevant for this audience, I am keeping my eye on the clock because we're going to open up in about 5 minutes for Q&A, was the question of career advice. So we talked a little bit about how data engineers and data scientists can work together. And maybe I'll go down, but I'll start with you, Vijay, as possibly the most senior, having worked at the biggest organizations. What do you look for when you hire a data engineer? What are the skill sets? What makes a resume stand out for anyone here who's at some point would love to work at a Salesforce or a Google or Microsoft?
So I knew Mike was going to ask me that question, so I prepared for that beforehand.
Predictive analytics,
right?
Good job.
So, right, what we are doing here is large-scale system design. This is pipeline design, machine learning, data engineering. They're all same, they're reflections on large-scale distributed system design. And I think the core competency that I try to hire for, sometimes I'm successful, sometimes I'm not, but it's hard to find out in an interview. And I wrote this down so I would repeat it with high fidelity. The core competency that I'm trying to hire for in this role is making good decisions on where complexity should live. Right, and this goes back earlier to Driscoll's point around should we process at the edge or should we process in a centralized fashion? And for example, if you're doing cheap sensors, right, the data cost of transporting the sensor data back is going to outweigh the cost of the BOM cost of putting the sensor out in the field in the first place. Right? So as a result, you don't want a whole lot of $1 chipsets sending $50, $60 worth of data over their lifetime to a centralized location, because data transport is expensive. Those you want to kind of winnow down as much as you can, as close to the edge as possible, because in general, right, cost for transport tracks distance. And then send the aggregated results back, ideally. If you're doing large scale, for example, credit card transactions where the volume is relatively small, but the monetization is very high, you want to do it in a centralized place. So those are the kind of things that I look for. Unfortunately, they're really hard to suss out in an interview. So sometimes you have to take a flyer, and then you have to fire fast.
So Sam, you're building out your team at SkipFlag. What, to the extent that you're bringing on data engineers, what do you look for? What makes the difference between a great data engineer and a not so great one?
I mean, I agree with what Vijay said that being able to understand where complexity should live is really important. I think the other thing that kind of gets overlooked is someone being very detail-oriented, especially with building data pipelines. There really is no objective truth to know whether you have the right data, is it the right way. Your sensor could be faulty, your pipeline could be faulty, some of the processing could be faulty. So you're making judgment calls and some sort of statistical analysis or reasoning to figure out exactly how everything data should flow. And it's also the other way too, when you have some models doing some sort of predictions. If you're doing that in a car, going 60 miles an hour, you really need to be able to debug that and understand that and do that in a reasonable and detailed way, and then you're getting the data in understandable fashion.
Okay, so you're now at Google, and I assume they're giving you a big checkbook, Ben, to hire and build out your group. What are you looking for to the extent that you're hiring folks to help write software to crunch Adobe PDFs for data?
Yeah. First, before I touch on that, I just wanted to add on to the point about complexity. I completely agree with that. Then actually the way that we approach our interview process, at least pre-Google, was forgetting about paying much attention to resumes or kind of standard interview questions or anything like that, and simply throw a complex, messy data set at them with a poorly defined objective and see how they handled that, and throw complexity at the candidate, then see if they managed to control and build on that complexity or ended up kind of falling flat on that. And that was by far the most effective way that we've ever interviewed for data scientists or data engineers.
Nice. So that's your answer, is look for people who can manage complexity. I used to have what I called the hacker test, which is I would give people a file at the command line, and it would just be a gzipped column of timestamps, and I would just ask them to convert Unix epoch into human-readable timestamp, and just wait and watch how long it took them to do that, right? And that was like, if they couldn't do that, if they can't do that in less than 15 minutes, they are not a data engineer, right? Because they'll never get past the step of unzipping the file and getting to the data. So the last question, then we're going to turn over to the audience, is really going to be about tools. I think about, all of us have been working with tools over the last several years. I guess I would sort of two-part question. One is, what are some of the old standby tools that you rely on as bread and butter anytime you have to go in and maybe change a column of strings into a Unix epoch digit? And what are some of the newer tools that you're most excited about? What new tools have come under the horizon in the last year or so that you're pretty excited about that could help this next generation of data engineers not have to do stuff the way we did and hand roll it? So I'll actually just go in order. Ben, you'll start again to put you on the spot.
Let's see, I'll start with an old tool that I newly discovered, actually. That's been a big change in my productivity. So before I say what that tool is, how many of you use a lot of tabs in your web browser? Say if I open up your computer and I see 50 different tabs open. How many of you have a similar approach to your terminal window or your command line interface? Okay, maybe a lot of you discovered this tool before me, but there's an awesome tool called Tmux, which is effectively tabs for a terminal that I got much more productive when I could treat a terminal window as lightweight as a Chrome tab.
Have you ever used Screen before?
Yeah.
Okay, so
Tmux works better.
Is this Screen on steroids?
Screen on steroids is a good way to put it.
All right, nice. Any other tools that, any other day-to-day tools that you're excited about?
How many people here use Docker as part of their data pipelines right now? Oh, wow, about half the audience or so. All right, we found that to be a really effective tool to help with reproducibility and have it so that 10 different people or 1,000 different people in our community can use the same set of Python environments that all work nicely together, instead of like having each person who starts in the same project go through like a headbanging day of getting the right either Python environment or our environment or software environment set up.
Wow, nice. Jay?
So I break it down into two categories. One is like data exploration tools. For example, how do you do ad hoc data exploration, and things like Jupyter Notebooks and so on and so forth are good ones for, or even Excel or GDocs, or I should say Quip now, I guess. You can use those for like ad hoc writing, forming the ad hoc queries. And then depending on where you are in the spectrum, right? So I look at like raw primitives, which are like assembly language of data processing, things like Heron from Twitter, or people may know Storm better, I guess it's older, or Spark, which are much more towards the raw assembly line. So you play around with your data exploration tools, you formulate the things, the transforms you need to do, and then you encode them in very low-level languages. And then there's stuff that is moving more towards the declarative side of the house, like Google Dataflow as implemented by Apache Beam, and I think Flink is implementing that. That's really awesome. We really love how clean that is. I think Matt Welsh had something to do with this, is the old Google Pinwheel stuff. And then after that, you have declarative, truly declarative, streaming declarative stuff like streaming SQL. Calcite is an example. Quickstep is another, although their planning optimizers are terrible, and I may have to rewrite some of that stuff. But that's kind of like where you have like you play around with the data, you figure out the transformations, and then you encode those transformations into systems, right? And then of course you run those systems using tools like Docker containers and Kubernetes for scheduling, so you have a reproducibility pipeline. The second one, which I think is actually even more important for me, is what is actually the data? Right? What I need is GitHub for data. Because as we evolve our algorithms and as we evolve our models, you can't reproduce the end results. You can't debug the end results unless you run the new model against the old data and vice versa. So you have to rev the data models. You also have to rev data, right? As I think Sam alluded very early on, is like, is it the data that changed, or is it the model? Is there a bug in the data or the model? So you know you have a gold set of data. How do you like reproduce the model and get the better results? So there's like people like Pachyderm, which are actually building stuff like that, which is just completely and totally awesome. We have our own stuff. But Yeah, reproducibility and versioning of data, or GitHub for data, I think is actually a huge component that can match data to models.
Nice.
So this is the bad part being at the end, because I do agree with a lot of things that have been said here. Let me add one more, which is I think is the Python machine learning stack. So that's relatively new. You have like NumPy, SciPy, scikit-learn. That's changed the ability to kind of get like a baseline V0 model from what would take like sometimes often a week before. Now you can do it like 30 minutes, an hour, and just set everything up with your cross-validation and everything and get something really quick off the ground. That can give you a very good baseline depending on your problem space. Then you can decide whether you really want to improve that model or not, but you can get something out very fast.
Okay, so I'm now going to open it up to the audience for some questions. And my ask will be if we'll pass a microphone around. So if you've got a question, raise your hand. We'll track you down. And you're welcome to direct it at one of the panelists here. What I generally try to do is I will take two questions. If there's more than one questions, I'll take two, and we'll select one. Sometimes that gives a little bit of a competition. But we've got one question here in the front, and then we'll take a second one, and we'll choose the better of the two. All right, you two gentlemen, go ahead. All right, first. And just say your name and what company you're with.
Sure. I'm Mark. I'm from New Relic. So this question is directed at all three of you, if you choose to answer it. So a lot of the conference today has been about some pretty advanced techniques and architectures, and a lot of them assume a very large, well-funded data engineering team. So what advice would you give companies that are just getting started in building out their data engineering and data science teams? Just generally, what advice would you give?
All right, we're going to just accept that question. That's a good enough one. No need for a bake-off. So, Ben, maybe who wants to jump in and answer that?
Yeah, I'm happy to, because until a month and a half ago, I was not a large company. I was a small Scrappy. One of the short summary was be scrappy with how you approach everything and be very focused on what works for your team in specific context. So we don't spend, like from a data processing standpoint, we try making all of Kaggle's data like easily available to everyone at Kaggle. And then beyond that, we don't build out a complex architecture. And a lot of what we do is actually, from an analytics perspective, if on Kaggle's internal data is just done in SQL, or from like competition setup perspective, it's done within a Jupyter notebook. So we tried staying like super focused on what we need to do instead of investing in any complex architectures that we didn't need.
Okay, I'm going to take the next question here from Pluralsight.
My name is Andrew. I'm from Pluralsight.
Pluralsight, okay.
So the question I have is, you were talking about team structure, and the question I wanted to ask is not necessarily the team structure on engineering, but more the team structure or the structure of the organization as a whole to make it more data-centric, and how you focus the organization as a whole to kind of care about data and think about data and ownership of data, because it's, oftentimes it's like, oh yeah, it's just this data engineering group over here, and you're always fighting the organizational battle of who owns data and how to make people care about data.
I'm going to make Vijay, who's been at a few big companies,
Okay.
who's probably fought that battle, so.
So in general, right, this is a human cognitive system problem. It's not an organizational problem. So generally, people don't want to hear answers that clash with what they believe. And so the best way I found is that you have data that can actually map to outcomes that are, you A/B test belief against data, right? And so the best way I've seen is like, okay, well, here's what we thought was going to happen. Here's what actually happened. Here's what the system predicted would happen. And then if you bring charts, it is hard to argue against that. If you come in, and other thing I found is like you want to like keep it as small as possible, because the larger the set of people who are like wrangling this decision, the more impassioned the arguments get and more imprecise the language. So you want to keep it into a few small key stakeholders and try to map output of the data processing or data engineering to a business outcome. Is that if you do this, you will get 10% higher revenue or 5% more click-through. And those are pretty hard to refute. I mean, you can refute them, but I mean, at that point, I suggest you go to some other company. But that's how typically I've approached it. And mostly it works, mostly.
Okay, other than that, I see someone in the way, way back here, gentleman in the beard in the bleacher seats. And we've got another, if there's 2 microphones, we've got another person right here as well. Yeah, but we've got someone all the way in the back. Do we have another mic as well? Okay, you'll go, I'll get you next. Can I go first? Okay, sure.
Hi, I'm
You're
Paul
next.
from Intermix. We help make your Redshift queries 100x faster. So what engineers do you have, or what advice do you have for data engineers writing unit tests to help to validate their data without needing an external dependency on the actual data source?
All right, Sam, I might put you on the spot. If you've written unit tests for your stuff, especially now that you're a startup guy.
So I think one of the, well, let me tell you a quick story. So one of the biggest improvements we've had at LinkedIn in one of our machine learning models was not anything that had to do with building a better, more sophisticated model, adding new features, anything like that. It was basically we had an ETL system that for whatever reason would only put out half the table. And it would drop the other half of the rows. Anything with an odd ID would drop. We didn't realize this for like 6 months.
Data fidelity.
And so when we did fix it, it had a huge boost, and I got a nice congratulatory call from the CEO. And it was basically because we didn't validate the data, right? And this is like the core problem of we just didn't know that the data was correct. And so you can write unit tests. I think that can be helpful to make sure that what you believe is true. The problem is what you believe may not actually be true. So what you want to also do is have statistical tests on the data to know, okay, how much is this data changing from day to day? Do I have a whole new set of keys? Depending on the type of data, or if I get a lot more volume, you can do a lot of tests on that, and that's the way we found is to make sure that the data that's coming in is the same that's coming out. You're not like accidentally dropping half the table and throwing away all this revenue on the table.
Okay, all the way in the back. Great, go ahead.
Hi, I'm Ed from Timescale DB. We are a brand new open source data engineering product, and my question is actually, what are the most important things you look for in data engineering tools, and what are good things that open source projects can do to be most helpful for you?
All right, I'm just going to get this last question is going to go to you, Ben, because you're a guy who has worked with a lot of open source tools, and a lot of, you talked earlier about MATLAB dying and SciPy, NumPy, and R on the rise. So what makes a great open source data engineering tool? What can someone who's building a new open source tool do to make theirs the choice of the Kaggle community in the future?
Making it super easy to use and well documented is with clear examples. Instead of going out with something like it is X% faster than something else or non-language that the end user cares about. Instead, here's how I used X to solve a problem. For example, Francois Cholet, who wrote the Keras package, did that for a couple of different super simple problems that we have on Kaggle. One's the MNIST data set for training machine learning, or for training a digit recognition problem. He had 3 or 4 examples up like that, and that helps Keras take off like wildfire in the community, because it's wow, it's really easy to train. I can take this code and drop it into my own problem pretty quickly. Then 3 months later, Google hired him, and now Keras is another really popular front end to TensorFlow.
Wow. Documentation and making the 0th order step really easy. Okay, that's all the time we have, because I want to make sure you guys have a chance. This is a conference. After all, the goal is to confer and meet all of the great folks here that you've been hanging out with. All of us, we're going to go down and get some drinks, I think, as well. So we look forward to seeing you down on the floor with drinks. And thank you. Let's give a good round of applause for our distinguished panel, Vijay, Ben, Sam. Thanks so much, guys.